Okay, on Monday, I introduced you guys to this format. Remember the vertex form? Raul? Make sure you watch the video. The homework's on the video. Alright, so oopsie. Here is vertex form for a parabola. Guys, I cannot talk over you. What you need to write vertex form is you need to know the value of A and you need to know the vertex. Well, that's what I gave you. I gave you the value of A and I gave you a vertex. HK stands for the vertex. Okay, so number one, all you had to do was plug in the A, the H, and the K and you would be done. Yes, so f of x equals 3 parentheses x minus negative 6, which is going to turn into what? X plus 6 squared plus 8. That's a very valid way to write the equation of a parabola, of a quadratic function. You can leave it just like this. H is the x value of the vertex, k is the y value of the vertex. The reason why they don't call it x and y is because you've got an x and a y also in there, so they needed to make up some new name for it. Plus, it's a very special point. It's a vertex, so they gave it its own little initials, h and k. Fernando. Yes, if you don't like f of x, by all means, y. And that's all I asked you to do with that. Okay, you could stop right there. Somebody said thought I was supposed to solve it. Well, first of all, this is just an equation. You don't really solve it, but you could rewrite it a different way. And yes, you are going to have to do that. In fact, that's what I asked you to do on number 2. And we did this Monday. Remember? This is already in vertex form. Can you tell me what the vertex of this parabola is on number 2? 4 what? 4, 6 is the vertex. That's one of the values of this form. You can tell what the vertex is by looking at it. And the value of A was negative 2. Now, if I want to put this in the other form, what was called standard form, then I have got to take care of these parentheses. 2 things are happening to this x. Well, 3 things. 4 is being subtracted from it, it's being squared, and it's being multiplied by negative 2. You have to do the squaring first. Here's where I'm seeing mistakes. Kids are forgetting that there's a negative 2 out here that is going to have to get multiplied by whatever you get for this mess right here. So please don't lose those parentheses. Just keep rewriting them. I've got to do x minus 4 squared first, which means x minus 4 times itself. So that's the first thing I got to take care of, squaring x minus 4. That's where you got to do that FOIL, first terms, outside, inside, last. That's going to give you x squared minus 4x, another minus 4x, and then what? Plus 16. And I can simplify that a little bit. X squared minus 8x plus 16. Now, I've got to multiply that by negative 2 still. So now I've got negative 2x squared. Then what? Plus 16x. Then what? Minus 32. Now the parentheses are finally gone, and now I can finally deal with that plus 6. That's the very last thing I could do. So I'm almost done. Y equals negative 2x squared plus 16x, and what's negative 32 and positive 6? Negative 26. Okay, so there's my answer. Now, on your homework tonight, guess what part of your homework is? Part of your homework is going to be converting your answer from this form to this form. Now, I need to clear something up, and I'm going to have to go back. If anybody knows somebody in first period, tell them I messed up. I'm going to have to go back and reteach this tomorrow, but you guys, I caught it before I taught it to you. But I think I did this on Monday, so let's talk about this. There isn't a third form, it's 2 forms. Yes. Okay, I don't really remember if I did this or not, but on Monday, did I tell you guys you could reduce this? Okay, let me correct myself there. You cannot reduce this. I mean, you could divide by 2, but you'd have to divide everything by 2, including the y. Yeah, but we don't want to do that. So, guys, please hush. Now, so if you get an equation like that, and I know I told you Monday to reduce it, the reason why I was thinking that is because I used to teach that when we did factoring. You can reduce this if you wanted to factor it. Because this and this, do you see what I did here? They're not really the same parabola. Do you see how this got divided by 2 to make this? But they would have the same roots. So that's why I ever let kids reduce a parabola, is when we were factoring, because it doesn't matter. These two parabolas are absolutely not the same, but they do have the same roots. So if you're finding roots and that's all you're doing, then certainly you can do that. But the reason why that's allowed is because when you're finding roots, it's not y anymore, it's 0. And so we're really dividing the whole thing by 2. 0 divided by 2 is still going to be 0. So please, 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 erase that from your brain. You cannot take a parabola like this. Yeah, you won't have any trouble erasing it from your brain. You can't really reduce that. You just leave it like that. Are we okay with that? Okay, now, a couple of things I want to talk about, folks. A week from yesterday, next Tuesday, in other words, you are taking your real mock test. That will count as a major... Guys, please let me talk. That will count as a major grade on this 6 weeks. It'll be a test grade. There are some things we haven't covered. I want to make a list of all the stuff we still have to do. One of the things that we have to do is what we're doing today. It's more with vertex form. After today, you'll be able to do that question. We still have to do scatter plots, which is not hard. That'll only take a day. We still have to do exponential functions, which again, we're probably going to do that tomorrow and Thursday. Won't take long. And we still have to do pattern rules. So most of these are 1 or 2 day lessons. Yes, they will be on the... okay, I am talking. Let me talk. They will be on the end of course exam. They will be on your mock test. Whatever I don't get to, as far as your Tuesday mock test goes, of course I won't count those, or I'd make them bonus. Okay, so this is what we got to cover before, and maybe a few other little things, before May 8th. That's when you take your real deal. And it's not that far away, guys. It's going to come up fast. So I still want to, we also need to review. We've been doing stuff since August. There's lots of stuff I want to go back and review. What, Chris? Yes. Okay, so I want to do a little bit of review with you. And make sure you're ready for the mock test and, of course, the real test. We're going to do a little bit of review in our notes, yes. Okay, so here is a, what kind of a parabola, I'm sorry, what kind of function is this? It's a quadratic function. How do I know it's quadratic and not linear? It's got an exponent. This is going to make the shape of a parabola, not a line. What form is it in? Vertex form. Vertex form. I want you to find the roots. You don't have to solve, well, you say solve it. You don't have to rewrite this in a different way. You don't have to put it in standard form. You can just put it in the calculator just like it looks. The calculator can handle vertex form. What else do you do to find roots of any function? 0 where? Y equals 0. The roots or the x-intercept or the 0 of a function, those all mean the same thing. That happens when y is 0. Okay, you calculate where they intersect. You put this in just like it looks. Y equals -2 parentheses x minus 4 close parentheses squared plus 6. You also put in y equals 0. What is y equals 0? No, what part of a graph is y equals 0? It's the x-axis. Because we're trying to see where this intersects with the x-axis. The equation of the x-axis is y equals 0. Okay, if you've got one of those nice calculators, it does it in 2 different colors. It does this one in one color, and then it does the x-axis in another color. And you want to see where they intersect. It's not going to be nice whole numbers. Second function, calculate intersection. Remember where some of you would not understand why your calculator wouldn't tell you the answer? This only works if you put in y equals 0. Otherwise, it'll keep waiting for second curve. And it's not a nice whole number because I just made this up. 2.267, right? Did y'all get that? How do I find the other one? Yeah, trace, get yourself over there. Second function, calculate, intersection, first curve, second curve, guess. And the other one is 5.732. Okay, then hopefully you get this one right on the test. All right, same parabola, just so we don't have to put anything else in the calculator. I want you to find f. Instead of y, let's write this as f of x. That's what they usually do. Yeah, it means y, exactly. Find f of -3. What am I giving you? An x value. You have to know function notation, guys. You don't want to miss the easy ones. These are the easy ones. This is me giving you an x value. Where do you find the answer? In the table. Tell the table to start at -3. That's one way to find the answer. There's more than one way. What's f of -3 for this function? -92. This is the x, and you are finding the y. You don't want to miss those. But some kids misread this and think that this is the y. That's not what's happening. Let me show you what that would look like. I want you to find out where does f of x equal -15? That's y, because what does f of x mean? Y. So it wants you to know where this equals -15. It's kind of like finding the roots or the zeros or the x-intercepts, except we're not finding the zeros, we're finding the -15s. Some kids try to look for that in the t-chart. Sometimes you might get lucky, but you can't control the y values in the t-chart. You can control the x values, but not the y's. So what's a surefire way to do this? Go to y equals. We're not finding zeros anymore. We want to know where it equals -15. Now, keep in mind, if the calculator can't see it, it will not tell you the answer. You can zoom out, or I just changed my window. My y minimum right now is -10. Well, I want my y to equal -15, so I'm going to change that to -20 just so I can see it. Okay, so here's my function. Here comes y equals -15. I'm looking for that point and that point. It's just like finding the zeros, except we moved it down to a -15. Second function, calculate, intersection, first curve, second curve, guess. 0.759 is one of them. Okay, that's what I just said. You cannot find this in the t-chart, because I doubt your t-chart is counting by 0.759 in the x values. No, it can't. You'd have to know to tell it that. See, look at the y values. I'm looking for a y value of -15. It skipped over it. Do you see what I'm saying? Because the x value that makes a y value of -15 is not a nice whole number, which is usually what we're counting by, is nice whole numbers. So no, you can't do this in the t-chart. When can you use the t-chart? When I tell you what x is, not when I tell you what y is. Okay, and there was another answer too. Did y'all get the other one? 7.24 something. Okay. So that's some things that I don't want you to miss. There's lots and lots of easy questions, guys. You can't afford to miss it. They have this stuff on there every year. Every single year there's problems like that. Square root of 68. Y'all remember how to do these? Did we? The wedding cake thing, they've had one of these every year. Super easy. You don't want to miss it. No, you don't just... The directions here are to simplify, not to give me a estimate. That's an estimate. Whatever the calculator tells you is an estimate. This never ends. It never stops. Okay, 68 can be divided by 2. Can I divide by 2 again? Yes. I did find one perfect square. What did I find? 4. So 68 is the same thing as 4 times 17. I'm going to go ahead and take the square root of 4. So when it comes out, what does it become? A 2. What stays in? The 17. This and this have the same value. What do you mean how to solve that? Well, you're not solving it. There's nothing to solve it. They might ask you to tell them what this is close to. Like the square root of 68, for example. The square root of 68 is a non-terminating decimal. Guys, the calculator ran out of space, but this is a good estimate for the square root of 68. I think that 2 times the square root of 17 is the same value. I'm going to see if that's true. 2 times the square root of 17, it should give me the exact same estimate. And it does. They're not going to ask you to solve this. Okay, another thing that second period brought up is domain and range. Okay, let's look at number 1. This is an exponential function, which we'll be talking about these in detail tomorrow. A vocabulary that you've got to know, asymptote. Remember the word asymptote? That's the line that it gets really close to, but it never touches, never crosses. That happens on every exponential function. Keep that in mind, because that will help you with range. I am talking. The domain here, what's the domain? All real numbers. Look at the left and right edge. If you see arrows, it's going on forever. That's all real numbers. Range, you got to think about that asymptote. Okay, it's going on forever to the top. But what's the lowest y value? There is no negative 0. Okay, 0 is what it's approaching. They're going to put both of these answers down there most likely. Y is greater than 0 or y is greater than equal to 0. Which one is it? Yeah, it's just greater than. It will never actually touch that value of 0. All right, number 2, a vertical line. Now, I didn't put nice big dots at the ends, but the endpoints are included. If I wanted to make sure that the endpoints were not included, they would have to put open circles there. If you don't see open circles, that means it's part of the graph. What's the domain here? Negative 4 is less than or equal to x is less than or equal to 2. Sometimes they'll go ahead and put nice big dots just to highlight where the endpoints are, but that means negative 4 is included and so is 2. The range is the top and bottom. Well, something weird's happening here. It's only got one value for all of the y's. What is it? Y equals 1. Every y value on this line segment is 1. All right, number 3, a vertical line. What's the domain of this thing? Yeah, all the x values there are 3. The range. Okay, you got to start with the lowest one. Negative 4 is less than or equal to y is less than or equal to 2. All right, look at these 3 functions. Just the first 3, or these 3 graphs. Which one is not a function? Okay, look at the first 3. Yeah, this is not a function. Vertical lines are not functions. If it passes the vertical line test, it's a function. This is. Is this? No, it fails miserably. The x's are repeating all over the place here. We've got the point 3, 2, 3, 1, 3, 0, 3, negative 1. Do you see how the 3 is repeating over and over? That's not allowed. The x's cannot repeat. Look at the other pictures. Are the other ones functions? Yes. Everything up here is a function except this one right here. All right, this is an upside down exponential function. It's still got that asymptote. The domain is still all real numbers. What's the range? Y is less than 0. All right, domain is the left and right. Please don't mix up domain and range. That makes me so sad. The lowest domain value is negative 4. Highest is positive 4. Good. It's less than or equal to x. Negative 4 was colored in, so I need that extra little line. But the 4 was not, so I don't put that line. That's what I asked for domain. Domain is always x's. All right, range is y's. The range would be the bottom and the top. What's the lowest y value? Negative 4. What's the highest? 4. And they are colored in on both. Okay, negative 4 is colored in and 4 is colored in. It's open at 3. But there is a y value of 3 right here. So 3 is one of the y values somewhere. This is only relevant for the domain in this problem. All right, a parabola. The domain of any random real parabola that goes on forever is all real numbers. No matter if you're given an equation, a picture, domain of a parabola is all real numbers. Only exception is if they cut off the arrows and put in points. Otherwise, it's all real numbers. Range is never all real numbers on a parabola. Range always depends on where the vertex is, specifically the y value of the vertex. So what's the range? Y is less than or equal to 4. All right, domain here. Lowest is -5, highest is +6. All of the other x's are in between. -5 is not colored in, 6 is. Are you with me there? Range is the top and the bottom. What's the lowest y value? 1. All of these, this whole segment has a y value of 1. What's the highest y value? 4. Is the 1 colored in? Yes. Is the 4? No, that's the range. Yes, a circle is not colored in. All right, now I need to talk about this, and then I want to give you another example, one that I have seen them do the last few years. You cannot write an inequality for this domain and range. If it's something you can count, you must make a list. Domain here actually is 6 things. It's not a million of things. There's millions of x and y values on all these pictures except number 8. So you cannot write an inequality. That would be incorrect. The domain, there is only a certain number of values. There's -4, -3, -2, -1, 1 and 2. Range. There's not as many range values because a couple of them are repeating. It's okay for the y's to repeat. It's still a function. 1 is the lowest. 3, 4, and 5. Now, please listen carefully because a lot of you missed this on the last mock test. You remember there was a problem about volleyball players, and it said something about there was 8 to 15 volleyball players on the team, and they were going to buy their uniforms, and the function for finding the cost of the uniforms is 25. I'm just making this up. I don't remember what it was. Y equals 25x plus 5. How much is each uniform costing? $25. This is some kind of shipping fee, a one-time shipping fee. That's the y-intercept. Now, it asks for domain. Or it either asks for domain or range. I don't remember. Okay, no. What's the domain of this? So there could be trillions of volleyball players on this team. They specifically told you how many volleyball players could be on this team. Okay, some of you did this, which is so wrong. Yeah, this is not correct. That means there could be 8.6 volleyball players. That means there's millions of fractional and decimal volleyball players in between 8 and 15. There's still a whole person. Okay, the domain here, guys. I need y'all to listen because they love these questions. The last couple of years, Demetria, I have seen these. You got to understand these. What is the domain? This is why I don't let you sit wherever you want to sit. Tell me the domain then. I'll forgive you if you tell me the domain. What is it? Exactly. That's the problem. 8, 9, 10, oops, I skipped 11. 11, 12, 13, 14, 15. That is the entire possible domain. There might be 8 players, 9 players, 10 players. Now, they could ask you for the range. Guys, I need your attention, folks. I'm not going to feel bad at all when y'all miss these on the mock test. How many range values are there? No. There's 8 range values as well. There's 8 domain values. That means there can only be 8 range values. Now, I would probably use my calculator to find the range values. Sometimes on problems like this, they might ask you, what's the highest possible range value? Well, the highest possible range value happens with the highest possible domain values. Sometimes they don't ask for all of the range. They might ask for what's the lowest range possible, what's the highest range possible. But if they wanted the entire range, we could list it. I would go to y equals and put in that function rule. 25x plus 5. Where do I want to start looking at my t-chart? No. 8. If I wanted to make a list of all of them, oops, I'd have to start at 8. Okay, so I'm going to go to my T-chart. I'm going to go to 8 was the absolute lowest number of volleyball players we could have. What domain value goes with that? 205. Then I would go down and find the range value for 9 players. 230. You see what I'm doing? All the way up to 15 players. So the highest possible amount we would have to pay? $380. But you'd have to actually list them all if they wanted a list of them. Yes. That's how many volleyball players we might have. In the test, it said, in the test problem, it said, people are trying out for a volleyball team. The coach is going to pick 8 to 15 girls. So there could be 8 girls, 9 girls, 10 girls, 11, 12, 13, 14, or 15 girls. It's not a scatter plot. It's just a list. All right, let's move on to homework. The homework that was due today. I am not going to pick that up because I'm going to give you a chance to ask questions real quick.
Pick it up and give them a 0.
Good idea. Edwin, you never stop laughing. Stop. Okay. If you don't have any questions, then that's fine. I'm just going to pick this up tomorrow. But some kids had questions. I want to give you a chance. If you don't have this done tomorrow, I'm going to be very angry. With work shown. Andrew? No questions on the homework? The 6-2, 6-3 worksheet? Pick one. Number 1 is like the easiest one on there. The one about Kate and Joelle? Okay, number 4 on 6-2. I'm going to help you set it up, but you're going to have to solve it. We have 2 people who went to the same store, and what we're doing here is solving for the price of these items. So you might get a decimal answer. Some kids get freaked out when they get decimals, but if you're looking for a price, that's normal. It said Kate bought 3 CDs and 1 DVD, and later on in the problem it tells us she spent $20. Please hush. Joel bought 2 CDs and 2 DVDs, and he spent $22. There's your system of equations. I would multiply the top equation by -2 and make the DVDs cancel, and then once you find the DVD, plug it back in to find the CD. I don't know. All right, anything else? All right, get out your notes then. This is due tomorrow along with the homework you're going to get today. All right, vertex form, day 2. Now, remember, you don't have to memorize the formula, but you do have to know how to use it. F of x equals a parentheses x minus h close parentheses squared plus k. What we're going to do today is we're going to have to find the equation. They're not going to tell us what the value of a is, but they're going to give us enough information to where we can figure it out. On number 1, the vertex of this parabola is 4, 6. Is that enough information to write the equation? Oh, okay. Go ahead then. You need an A, exactly. Go ahead and write in what you know, though, because this is what I would do on your first step. There's lots of stuff we're going to have to plug in, and kids start making mistakes when they try to plug everything in at once. So the very first thing I would do is just look at your vertex, plug in everything you know into your formula. I'm going to use y instead of f of x. Are you okay with that? What do I not know? A. The A is still there. X minus 4, don't forget the squared, plus 6. So remember, if you need to write this above your vertex, h and k are the vertex, the x and y of the vertex. We're almost done. What's the only thing I'm missing? Christopher, are you writing these down? Okay, I'm going to use this when I get my final answer. When I know what A is, all I got to do is go back here, erase this A, and put in what it actually equals, right? Okay, so here's what I'm going to give you next. Right now you don't have enough information, but I'm about to tell you another point that is on this parabola. Just another random point. The random point that I'm going to give you is 2, 2. No, let's make it different. 2 comma 2 comma 8.
Really? Are you serious right now, man? Are you serious?
Okay. Now, the vertex has to go where H and K are. Okay, that's why I always like to put that in first. This is just a random point. It's just a random X and a Y. Do not go to stat. You cannot find the equation of a parabola with only 2 points. It will not do it for you. You're going to have to do this manually. The calculator cannot do this for you. All right, where do I put the 2 and the 8? Where X and Y are. So instead of Y, what am I going to put? 8 equals A, I still don't know. Instead of X minus 4, I'm going to put in 2 minus 4 squared plus 6. Now we're going to solve this equation for A. It's kind of like when we had to plug in the slope and the point to find the y-intercept, to find the b value. It's kind of the same thing. You have to do parentheses and exponents first. What is 2 minus 4? Negative 2. What is negative 2 squared? Positive 4. So now this is 8 equals A times 4 plus 6. How do we normally write A times 4? 4A. So I'm just going to flip that around. Instead of A times 4, I'm going to put 4A. Are y'all okay with that? Now what? Subtract 6. You get 4A equals 2. What does A equal? 1/2. Now I go back to my very first step, and now I know the whole answer. I'm going to take A out, and what do I put in its place? 1/2. This is the answer right here. Y equals 1/2 parentheses X minus 4 in parentheses squared plus 6. All right, let's try another one. I don't care. All right, number 2. Number 2, the vertex of the parabola that I am thinking of is -1, -3, and just a random point on this parabola is 2, -12. Okay, do we need to do this one together? No. Shut up. Okay, guys, stop that. Stop it now. Okay, I would not try to replace X, Y, and HK all in one step. A lot of kids did that. Whenever I try to do that, I end up making mistakes. What I do is I first replace just the vertex, because that helps me when I write my final answer anyway. So Y equals A parentheses X minus -1, which turns into X plus 1 squared plus K, so minus 3. Are you okay with that? Do you see what I did there? Then, in my next step, then I would go ahead and plug in the random point for X and Y. So that's going to be -12 equals A parentheses 2 plus 1 squared minus 3. How is that 2/3? Maybe you're too slow. All right, now, so all I did is in the first 2 steps. The first step I plugged in H and K. The second step I plugged in the random X and Y value I gave you. Now we're about to actually start the equation. What is 2 plus 1?
3.
And 3 squared is 9. So this becomes A times 9. Are y'all okay if I just write that as 9A? Okay, what is 2 plus 1? What's 3 squared? Okay, now add 3 to both sides. What's -12 plus 3? -9 equals 9A. What does A equal? -1. Now, because of the way I did it, All I got to do is go back to this step right here and take the a out and put in a negative 1. Which they probably wouldn't even put in a negative 1. They'd probably just put in a negative sign. Okay, well, if you would listen instead of being silly and crawling, and 2 plus 1 is 4. You're not even listening. All right, next problem. Guys, I am so tired of the constant talking and silliness. Here's your 7, Christopher. Okay, I want these to work out to be nice, easy numbers. Okay, these are rigged to where they'll be nice, easy numbers. Now, on your homework tonight. On your homework tonight, you're going to have to give me both forms. Vertex form and standard form. First, let's find vertex form. We can't find standard form yet anyway. We don't have enough information. Are y'all already doing this? Okay, I am telling you guys, if you're making mistakes, I would definitely break this down into 2 parts. The very first thing I would do is just rewrite the equation, only replacing h and k. Then I would replace the y and the x value. Then I would solve the equation. 7 equals 3 minus 2 is 1. 1 squared is 1. This one was easy. What does a equal? Negative 2. I don't know. All right, now I still have to go back and put that into my answer. I found out what a is, so I'm going to go back to my first step and replace a with negative 2. And there is half of my answer right there. That is the vertex form. Now, I'm also going to make you give me the standard form. Just like we did on the warm-up. So, take that and convert it to standard form. Do x minus 2 times x minus 2. Then multiply that by negative 2. Then add 9. That's how we just did it. I don't even know. You're not even making sense. Okay, if I hear that one more time, you're going to be writing it 500 times. Alright, x minus 2 squared, guys, becomes x squared minus 4x plus 4. So please be careful. This is the part where most mistakes are made, where you're taking x minus 2 and squaring it. Then distribute the negative 2. I'm getting negative 2x squared plus 8x minus 8 plus 9. And now I'm almost done. Y equals negative 2x squared plus 8x plus 1. There's the other version of that same parabola. That's vertex, and this is standard. So what's new? Alright, try this one please. Vertex is 2, 2. Random point on the parabola is 4, 6. And give me the answer both ways. Okay, you said it and you said it. So 250 for you, 250 for you. Your mom.
You said it twice, that's 500 for you. But what do you mean? He said, you're not. Wait. 570. Did I write it like you are? Miss, he said it. Put on.
You are mom.
I didn't say you're.
Okay, both of you. I'm not kidding. 250 times.
No, you gotta say you were. If I got A equals 1, I'm just trying to do my work. You should do you are mom.
You're never just trying to do your work. That's part of the problem.
I got A equals 1. Wait,
Just what they said, yes. All right, are you done with this? I want both answers. There isn't. We just did it like 3 times. You square the binomial, you distribute the A, and then you add whatever was at the end. Yes, you do. 250. Yes. 250 times. Okay, then watch it, please. Okay? First, let's do point slope. Pay attention. Y equals A parentheses X minus my H value squared plus K. The vertex is your H and K. Okay, are you with me there? Oh, no, you don't know how to do it. You stop listening. I don't know when you stop listening. 6 equals A parentheses 4 minus 2 squared plus 2. I plugged in my X and my Y. 6 equals A. 4 minus 2 is 2. 2 squared is 4, so it's 4A plus 2. Subtract 2. 4 equals 4A. This is part of the problem right here. A equals 1. So I'm going to go up here and put A 1. Now, probably if A turns out to be a 1, they probably wouldn't even write anything at all. Okay, so there is my one of my answers right there. Now watch carefully for the 4th time we've done it today. I want to put this in standard form. Usually there's a number here, so keep that in mind. This one's a little bit easier because my A value ended up being a 1. I've got to do X minus 2 squared because exponents come first. So I'm going to do X times X. X times negative 2. Negative 2 times X. Negative 2 times negative 2. So that gives me X squared minus 4X plus 4. Now, usually your next step is to distribute the A value. Okay, so keep that in mind. But the A value here is just a 1, so it's not really going to matter. So this is just going to be X squared minus 4X plus 4. And don't forget there was a plus 2 at the end of all of this. Up here. So the final version, the final answer here is Y equals X squared minus 4X plus 6. Now, here is a way, guys, please listen. Here's a way to at least make sure you converted correctly. This won't tell you if you did this part correctly or not, but it will tell you if these two things actually equal each other. I'm going to go to Y equals and put in my answer in vertex form. Y equals 1 parentheses X minus 2 squared plus 2. And then I'm also going to put in the other version of Y equals X squared minus 4X plus 6. They should be the exact same function. So I'm going to look at the t-chart. I should be getting the same Y values that on both of these functions. Am I?
Yes.
Yeah, because they're the same function. Just one's in vertex form and one is in standard form. That's what you're doing for homework, and I'm only giving you 4 problems. But I want both answers. All right, here is your homework. So, you just like we just did, you find A and you write it in vertex form. And then after you find it in vertex form, you convert it to standard form. So you should have 8 answers when you are done here. Yes, you can.